In this lesson, we have two examples to learn about digital read. In the first example, we are detecting a push button. When it is pressed, we will print something on the screen as 1. When it is not pressed, it will be printing 0. On the second example, we are going to use a read switch where a field is detected. When we bring a magnet close to it, it establishes connection. When magnet is away, it disconnects. And we are going to learn how to use a push button without any resistor with Arduino. Welcome to Arduino course by Robojax. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax. In this lesson, we are going to learn using digital read, where we can read the digital state of a pen or digital state of a device either as high or low. In this case, high is 5 volts and low is 0. Usually high starts about 2.2 volts and higher, and 1.5 and lower will be treated as low, as 0, but depending on the system they might vary. So we are using digital read to read the input of Arduino. For this lesson, we are going to use a push button, and we are detecting the status of a push button, whether it is pushed or not. And in the second example in this lesson, we are going to use a read switch, which is a magnetic sensor, a switch that is being turned on when magnetic field is getting closer to it, and it will turn off when magnetic field is away or not detected. And we are going to learn how to use a push button without any resistor with Arduino. This is a push button switch where when you push it, it just connects 2 wires or 2 pins of this switch and establishes connection. This is exactly the same as a switch like this, but the difference is that when you move this in a different position, it stays, but this push switch returns. It clicks. When you release your hand, it disconnects. You might see a push button switch something like this, where you push, it connects, and release, disconnects. Now let's have a look at the switch, how we connect it to the input pin of a microcontroller such as Arduino. This is an example where we have connected a resistor from high, let's say 5 volts, or in some Arduinos which are working with 3.3 volts, it will be 3.3 volts connected to the pin, and the high is received because the switch is not connected. These 2 pins are not connected to the ground, so high is there. Once you push the button or turn on the switch, then the low signal will go. That resistor is already there. When you turn it off, immediately it goes to high. So this way we can have high or low when you press the push button. So remember, this was when you pressing push button, you have low. You can connect it the other way. Now when the push button is not pressed, resistor is connected between ground and the pin. Before, it was connected between the pin and high. Now it is connected to the pin and low, or the ground. When the push button or switch is not on, the pin receives low signal. Now when you press the push button or the switch, then the high signal will receive by the pin. We are going to connect a resistor with a push button to pin 2 for this example via a 5 volts. When we press the push button, we read the high or low signal from this pin 2. I've just explained it. So the resistor could be connected from pin to ground or from pin to 5 volts, but in this case, as you can see, it is connected to ground. And here is the wiring. We have our push button connected. This side, we have 2 pins. This pin is connected to here, which is connected via this line to 5 volts. So the whole line here, this area is 5 volts. And from this pin, we have 1 wire to pin 2. And from the same pin, we have a resistor 10 kilo ohm to a point, where from that point it is connected in here. And from here we connect it. This is a good practice because we have now 5 volts and we have ground, so we can use it. But if you don't want to use this extra 2 wires, from here we can directly connect to ground, and from here we can connect it directly to 5 volts. Now let's do the wiring. I'm using this 10 kilo ohm resistor that is provided here. We need only one. As you can see, 2 of them are on one side, 2 on the other side. This pin is connected directly to this pin, and this pin is connected to this one. Here I'm connecting it like that. You see the breadboard, the red is on this side, and here is also on this side. And then I'm getting this 10 kilo ohm resistor and connecting it to this pin. This line is connected to the same pin. And doesn't matter where you connect it next. We can use that, no problem. And then this wire will go to the pin that is connected, and I'm going to connect it to the side that is red. So now I'm going to connect this from the resistor. I'm going to connect it to blue line, this side, which is all my negative. So it doesn't matter, I'm just connecting it like that. I have one wire that is connected somewhere to this red, another wire somewhere to the blue side. So this is my ground and 5 volts. Now we need to have from the second pin where the resistor is connected, a green wire goes to Arduino. The green goes to pin 2 like that. The red goes to 5 volts, and then black goes to ground. You can connect it to that ground or to one of these grounds. So the wiring is now completed. When you open Arduino next time, usually it opens the last sketch or program that you have worked. Let's open our program. Now go to File, Open, Download SunFounder 3-in-1 Kit, Learning. So 3.1 read button value. Open it. And as I mentioned, this is all comment. Here we have defined here pin 2 as push button. So now this is holding the value 2 for us. Inside the setup, we initialize the serial monitor with 9600 baud. So this can print some information for us. This line is defining push button, which is pin 2, as input. Now pin 2 is an input, and this setup is done. Let's go inside the loop. Let me press enter so we can go a little higher. Inside the loop, we use DigitalRead. DigitalRead is a function where inside the parenthesis you put the pin and it reads the status of the pin, either high or low. So this cannot read in between. So this is digital, so digital means it reads only high and low is returned as 1 and 0. 1 is high and 0 is low. And the status that we received from this reading is stored in a variable called button state. So this is integer and is holding the value as 0 or 1. This button, push button, was also integer and this was holding it as a number, so this is 2. But this one depends on the status of the push button. And then we say serial print and it will print the whatever is this, either 0 or 1 to the output. Because now our circuit is connected via a resistor to ground, it's always low. When we press the push button, it will go high. Let me connect the Arduino. Now it's connected. Let's select the board, upload the code. Compiling, uploading, done. Now let's open the serial monitor by clicking on this button here, and this is our serial monitor. And here make sure that this is 9600 baud, because in our code we have defined it as 9600. So if this doesn't match, you will get error. Only if we have 1. So now let's press this. As soon as I pressed, you saw this was going very quick. We can reduce the speed here, like 200 milliseconds, but it will not detect faster. Let's upload it. But at least it will print it slower. Now click on serial monitor. We can see it in here, and let me press it. You can see in here it is printing. This is a reed switch. Metal is inside a glass capsule where it's protected from dust, but when you bring a magnet closer, it establishes connection. When you remove it, it disconnects. So this acts like a switch that connects and disconnects these two wires. Now I'm going to test this reed switch with the multimeter. This is K-Weeds KM601. I've done the full review of this. This is very beautiful, nice multimeter, around $30 Canadian or $30 US. The link is below the video if you want to purchase it. This is automatic, so it checks whatever you want. It will measure. If I do a short circuit, it detects it. It stops at buzzer, and it's called continuity tester. So it tests. If I disconnect it, as you can see, it detects. Now, and here, as you can see, because the reed switch is now open, these two wires are not connected. Now I have here a magnet, so you can have smaller magnet, doesn't matter. This was in my hand. Now if I bring this, the magnet will make the contacts reach each other and the circuit will be closed. So we can detect magnetic field using reed switch. Here I have a small magnet. Let's bring it closer. As you can see, it detects magnetic field. We have just, everything is the same except we have replaced the actual switch or a push button switch with reed switch. the same way connected to pin 2, and pin 2 is connected with a 10 kilo ohm to ground. And here is on the breadboard, from this point where the read switch and 10 kilo ohm is connected, from the same point it is connected to pin 2, and then resistor is coming to ground via this wire, or you can connect it directly from here to ground. Read switch is connected to this point where it is connected to this line, and from here we have to connect it to 5 volts, or you can connect it directly to 5 volts. Now let's do the wiring. Let's bend this from some point like that and just insert it at somewhere on breadboard like this. So the read switch is connected on the same pin that read switch is connected. Connect to your resistor, and then the other pin somewhere, not on the same line but somewhere else, either this side or this side. Now from the resistor, put one black wire and put one red wire to the read switch on this side. From the common point, we are going to connect this green wire and connect it to Arduino. So from green we'll go to pin 2, black goes to ground, red goes to 5 volts. Wiring is complete. Now this is the same code as before. If we look at serial monitor, and if I bring this magnet, you will see that we are reading here 1. Let me zoom in. So pay attention to these zeros, that if I bring this, you see we are reading 1, 1, 1, and if I remove it, it will be 0. Let's open the actual program. Open, downloads, SunFounder, learning, and 3.2 feel the magnetism. Open. Here is the code. This is the same as before, except they changed the name from push button to read pin. Again, we are defining the serial monitor with 9600. We are setting using pin mode, this pin as an input, and inside the loop, this time we are just reading the value. Before it was like this. We had it integer value like that, and then the value was in here printing. Now because this is returning the value for us, we can just put it directly there without having to have extra variable. So this is getting the value either as 0 or 1, and 0 means no magnetic field and 1 means magnetic field. Now they put it as 10. Let's upload the code. And here I have this small magnet. First let's open the serial monitor. It is printing 0. Let me increase the size so you can see it maybe better. That's bad. Now you can see the 0. I will bring this closer so you can see that. It is now here 1, remove 0, close 1, remove 0, so we can detect magnetic field. Pole, it works. 0, so it works from far away. There is another trick in Arduino and some other microcontrollers that they have something called input pull-up. When the switch is not connected or there is nothing connected at all, you can set it to something called input pull-up. It pulls this pin up or connects it to high. This side is high and there is a resistor. Internally it is connected. So you do need to connect the external resistor just to your switch. When you connect your switch, then you are connecting this pin to the ground and the pin receives low signal. Now let's see, if you don't have a resistor, what is the problem? If you don't have a resistor, let's say the push button or the switch is on, then we receive a signal to the pin. This pin is high. Now as soon as you turn it off or release it, then this pin has no status. This is neither high nor low, and it will be floating. Sometimes it shows unpredictable behavior, high or low. So it's never advised to use the input if you're connecting it with a switch without a resistor. So you must have a resistor, or you have input pull-up enabled for the pin. And here is the wiring. I've connected one side or one wire from the push button to pin 2 and the other to ground. This is the case where we do need a resistor, and we will use input pull-up. And here is the code for using pull-up. So we have defined pin 2, the same thing as before. The only difference is in here. Before it was just input without this pull-up. Now I've added pull-up. When you add input pull-up, you don't need any resistor. The rest is the same, except I've added this line, so this will also print a text for us. Let me connect Arduino and upload the code. Upload completed. I'm opening the serial monitor here. Push state is 1 because we have pull up. Automatically it shows 1. When I press it, it shows 0. Pay attention here, it is 1 now, and when I press it, it is 0. Release 1. Push 0. So we don't need any resistor. As simple as that, we can detect it.